Hello, my name is Mofi, a developer advocate at Google, focusing on batch and AML platforms.
Hey, my name is Maciek Różacki. I'm a product manager working with Mofi. I'm responsible for defining some of the roadmap items that we will talk about, oriented on batch computing and AI/ML training on GKE.
And I'm Ali. I'm a solutions architect at Google. I partner with Mofi and Maciek in helping our customers build high performance and batch platforms on Kubernetes.
What a year for AML has been for GKE. And in this video, we'll detail all the details and all the things we shipped to make your life running AML workload on GKE easier.
So let's start off with TPUs, tensor processing units, a crown jewel in current accelerators technologies on the market. This is the technology that stands behind the latest Google's innovations. And we've made significant launches and shipped a lot of interesting capabilities to help you use the same hardware and the same software and resources and tools that internal scientists and researchers that are DeepMind, Google Brain, and other divisions of Google are using to improve our product that all of us use daily.
So, what's new? TPUs are generally available in GKE. We announced at Next 2023 in August the preview of Cloud TPU v5e, which is now generally available.
TPU v5e has been GA and offers fantastic price per performance. TPU v5e in our test achieves a 2.3 times improvement in price to performance ratio compared to the previous generation of TPU v4. TPU v5e offers the same training performance of the previous generation while saving 56% of your TPU running cost.
TPU multi-slice is our technology that allows you to combine massive scale of distributed TPUs into a single training workload that gives you a combination of scale and efficiency.
There are new TPU v5e machine types that are specialized for inferencing. They contain 1, 4, or 8 TPU v5e chips, and they're currently available in US Central 1A and Europe West 4B zones.
We released the new toolkit for training massive AI workloads. We released XPK, Accelerated Processing Kit, which is a software tool to help cloud developers orchestrate training jobs on accelerators such as TPUs and GPUs on GKE. XPK handles the multi-host pods of TPUs and GPUs as first-class citizens.
As we're making TPUs available to you, we're also enriching your experience using these accelerators with additional observability and monitoring capabilities to help you fully leverage the horsepower hidden in these accelerators.
On the side of security improvements, starting in GKE version 128.1, TPU workloads in GKE have privileged mode enabled, which makes it possible for an improved security posture for your workloads.
And as part of the latest Gemini model announcements, you could also hear that we've announced the AI hypercomputer capability that is coming to Google Cloud. It includes GKE capabilities that will give you access to v5p TPU architecture that was used to train Gemini model.
GPU is a key part of your AML portfolio on GKE. GPU enables the portability our customers need to run their AML workload in multiple environments. Over the last 1 year, we have made many improvements to improve the quality of our customers' life.
On the GPU side, A3 VMs that are powered by NVIDIA H100 GPUs are now generally available. These VMs are optimized for GPU supercomputing and offer 3 times faster training and 10 times greater networking bandwidth compared to the prior generation. A3 is also able to operate at scale, enabling users to scale models to tens of thousands of NVIDIA H100 GPUs.
The G2 VM became GA earlier this year. We recently announced fantastic MLPerf results for the G2, including up to 1.8x improvement in performance per dollar compared to a comparable public cloud inference offering.
GKE Autopilot now supports L4 GPUs. Autopilot is the easiest way to use Kubernetes on any cloud, and with already existing support for T4 and A100 GPUs, now with L4s also, you will have a fantastic platform for running your inference workloads.
We now install the GPU driver automatically at the time of node creation. As of release 1.27.2, we install the GPU driver for NVIDIA GPUs automatically, so no more installing the daemon sets manually.
To help you get sense of what's happening inside the cluster, a GPU dashboard is also available on the GKE clusters details page. In the Cloud Console, viewing a specific GKE cluster details The Observability tab of the cluster now includes a dashboard for GPU metrics. This provides visibility into the utilization of GPU resources, including GPUs by model and by Kubernetes node.
Ray is at the moment one of the hottest open source frameworks used to train machine learning models. Using Kubernetes to host the Ray clusters is the default way how customers who value portability and elasticity leverage this framework on Google Cloud.
To help our customers understand this Ray ecosystem and Kubernetes together, we have published a number of tutorials and blog posts. This includes getting started with Ray on Google Kubernetes Engine, guide to using Ray on GKE with TPUs, and most recently, Sarvin LLM on L4 GPUs with Ray.
The Kubernetes ecosystem has a rich orchestration layer for your containerized workloads. In the last couple of years, we've added a number of core capabilities in Kubernetes to make it a great place to run batch workloads. Let's take a look at some of the improvements both at the core layer and at the ecosystem layer. GKE is now supported in the HPC toolkit to simplify landing zone creation. The HPC toolkit is a set of open source tooling that is put together to help customers quickly onboard workloads and platforms onto Google Cloud. Q, which is a job scheduling add-on and a quota management system, has graduated to beta as we ship 5 feature-rich releases. This includes support for Ray jobs, bare pod support, as well as Qflow. There have also been a number of improvements in the job API over the past few years. For one, they support scalability on par with deployments. In addition, you can also supply semantics for restarts and what to do when a job fails.
The amazing boom of artificial intelligence has created massive demand for the latest generations of advanced hardware accelerators that are necessary to build these models. We've made a number of improvements that help you optimize your access to these advanced resources. First, we've made Dynamic Workload Scheduler available on GKE through the Provisioning Request API in Cluster Autoscaler, which gives you access to additional capacity of all of our accelerators. While the Dynamic Workload Scheduler is a capability that allows you to request accelerators and wait for them when they will be available, future reservations give you the ability to plan when you will be able to use the capacity of computing power that you need for your workloads.
In machine learning workloads, your model is as good as your data. We have made a bunch of improvements to make that data access and use in your machine learning model much easier. Google Cloud Storage Fuse is generally available. GCS Fuse can reduce pod startup time by up to 40% and improves the portability of your code by enabling access to GCS data using file semantics.
Let's take a look at some of the recent publications that help you deploy batch and machine learning workloads on GKE. You can find the links to all of these publications in addition to all the resources we talked about earlier in the video in the description below.
Thank you for an amazing 2023. We can't wait to see what awesome things you build with these tools. We hope to come back in 2024 to bring a list again of all the things we'll be doing in 2024. Until next time.